Assalamualaikum. Good afternoon, guys.
Good afternoon, sir.
Good afternoon, sir.
Okay. We have the uh, rules that we already uh, make use of them in order for us to come out with the sketch of the locus. And we actually add rule number 4 or number 5 at least. So do you have anything that you need further clarifications, things like that? Anything, guys? Can you see my sharing? Guys, can you see my
Okay, sir.
sharing? Anything that you would like to ask? We actually has reached up to this step number 3. But the fact that if let's say we look at what that we have in the rules, it's already more than 3 rules that we have already have in our consideration for this root locus. Anything? Okay.
No, sir.
All right. So let's move on. This is going to be the next rules of the steps that we are going to take in order for us to come out with this root locus plot. It will be on this behavior at infinity. It will also be known as the asymptote. What that we are going to have in this, we are going to determine the point that is actually point that will be on the real axis. There will be one point that we will call it as sigma A. So this point is going to be the asymptotic or the point that we refer to the asymptote point. So we call it as a sigma A. And then we are going to have the asymptote angles or behavior at infinity angles. And we are going to name it after this theta A. But anyhow, the conditions of this theta will be sort of in the condition that possibly will be more than one. So we are going to use one variable that is known as k. So the next question is, if let's say it's not going to be more than one, and then when it's going to stop? So the k value that we are going to have it to be began with 0, and we can take either +1 or -1. So normally we are going to take this +1 to be in our consideration because both sides, they are just going to be the same. The k value will be n when that we have the repeated outcome of our consideration. Says that we are going to have the condition of theta k equal 0, it will be 60 degree. Then the next k at k equal to 1, we are going to have it to be 180 degree. Once it's come to the next k that is equal to 2, probably we are going to have it to be as 300 degree. As we take the K to be equal to 3, then we are going to have the value as 420 degree. This 420 degree is the point of which it will be repeated the same point or the same angle of 60 degree. Got the idea? Guys? Does that make sense to you? Any question? No?
Is it possible to re-explain it, sir?
Which part that you want me to re-explain? I won't re-explain everything. Which part? Which part? Whoever that asked me, which part that you want me to re-explain? Hello?
The part where we
We are going to stop for the consideration of K. Or which one? Yeah, okay. Let's look at that. We are going to have two consideration or two value that we are going to look for. One that is going to be theta A. Normally, just going to be 1 point. Then we are going to have theta. So theta will be the theta that we also refer to the theta for the asymptotes or the theta for the behavior at infinity. But we use this theta to be under the consideration of asymptote instead of behavior at infinity. Since it can be within k equals 0 and so on and so forth. So we normally going to begin our consideration at k equals 0. Then we are going to have k equal 1. Then we are going to have k equal 2. Then we are going to have theta k equal 3. Then we possibly going to have at when the theta k equals 4. That will be all of the possibilities. But now, when we do have the such thing that we need to consider, of course, there will be a questions that we are going to have when that we are going to stop considering the next K. So it will be stop, or we are going to quit by looking for the consideration of the angle for the, I'm going to have this to be as the increment of K. At once the condition of the outcome for the angle become the angle that repeated what that we have had earlier. Let's say we are going to have at theta k equal to theta k equals 0. Is equal 60 degree. Then when we come up to theta k equal 3, we are going to have it to be as 420 degree. Then we will stop. We will no longer look for the k equal to 4. Because at this point, when k equal 3, we are going to have it to be as 420 degree. It's already repeated this same angle. Got it? Hello? Any question?
yes, sir. No, sir.
Okay. Good to know that. Right, so this is going to be what that we supposed to have for this theta A. Let's get back to the rules because we haven't looked into this in the equation before this. Now let's look at this behavior at infinity in general explanation. So the theta, the sigma A will be the value that under the consideration of summation of finite poles minus a summation of finite zeros over a number of finite poles minus number of finite zeros. So whatever the value that refer to these poles will be summed together, all of them. Same goes to the value of the zeros. We are going to total them up for the numerator part, and then we know what that is going to be the number of poles and number of zeros, and they are actually one of the first consideration that we are going to have in order for us to come out with the root locus. And then we are going to have our sigma A. And as for the theta A, it is equal to 2k plus 1 times pi over number of finite poles minus number of finite zeros. Okay. Guys, anything? As this is going to be something that just a general equation. Do you have any question? Are we going to have this to be in difference when that we use k equal to minus 1 instead of k equal to 1 only? Are we going to have the such difference? Guys? Or they will be just the same? Guys? I need to know your response. Guys, your opinion on my question. If we use k equal to plus 1, is it going to be the same as we use k equal to minus 1? Guys? Hello? We have got just two values that we need to find, and k will only applicable for the theta A. My question, if I change the k, instead of I'm going to use it to be 1, I'm going to use it to be as minus 1, will it be any difference to compare to plus 1?
Sir.
Hello? Would it be any difference? Guys? Can you hear my question clearly, guys?
Maybe no kot, sir.
Okay.
No, sir.
They won't be the same. Was that what you mean?
Yes, sir.
Okay, that's good to know. Okay, right. Let's look at this. When I explained to you last time, I'm just going to go for this. My explanation was just on k equals 0, 1, 2, 3, and so on. Am I going to be like so lazy to consider on this k equal to minus 1, minus 2, minus 3? No, they are actually just the same because this is something to do with 180 degree. Try to substitute it, guys. If k equal to minus 1, what would it be? 2 times minus 1. We are going to have it to be as?
3, sir.
No. Let's consider it in exact. Once k equal, if let's say k equal to minus 1, what will you get? 2 times minus 1. Am I right? Yes, guys. Look at this. 2 times minus 1. For the k equal to minus 1. 2 times minus 1 plus 1 times 180 degree. What would it be? Hello.
Negative
Negative 180.
540.
Negative. Come again, yes. Negative.
540.
400.
5, sir. 540.
540. Okay, that's good to know. 2 times minus 1, it will be minus 2 plus 1. Then it will be
Negative 1, sir.
negative 1 times 180 degree. Then it will be minus 180 degree. Am I right? Am I
Yes,
right?
sir.
Okay. Then, if let's say this is going to be on the k equal to minus 1, and the opposite sign of it will be 1. When k equal to 1, then it will turn up as I'm going to have it to be 540 degree, as you have already answered on the considerations of this earlier, but your answer referred to the minus 1. But actually minus 1, you are going to get minus 180 degree, and 1, you are going to get 540 degree. Are they the same point of angle? Guys, (540 degree), is it same as minus 180 degree?
No, sir.
Goodness me, guys. This is how we determine the angle. We are going to have the direction of anti-clockwise, to have it to be as positive 180 degree. Am I right? And the same angle, the same point, the same whatever line that we are going to have for 180 degree will be for minus 180 degree. Am I right? You know, guys. Am I right on this? This is plus 180 degree, and this is minus 180 degree, and they are actually the same point and the same line. If you want to have a line to show 100 plus 180 degree and minus 180 degree, same goes to this one. Because if let's say it is going to be 540 degree, how are you going to have it on this? This is 360 plus another 180, then it will be 540 degree. Got it, guys? No. That's why, in other words,
Okay, sir.
I can simplify my explanations of this minus 1 plus J naught is actually equal to, if let's say I'm going to be so like a clear-cut explanations, or something that on the simplifications of how that others can imagine what will happen if I convert this rectangular form to polar form. I will just be saying that I'm going to have the magnitude will be 1 and the phase will be 180 degree. And this form of 2k plus 1 is actually the form that in the equation, no matter what that will be the k value, it will always be 180 degree. That's why when we have the consideration to prove either what that we have had will be the one that on the root locus plot for this one. Yeah, B and A. So that's why the sum of angles that equal to 180 degree means something that we can actually have it to be as the proof how that we can have it to be as the point is actually on the root locus. You got the idea now, guys? No. Okay, I'm just going to, I know that all of you can understand English well, but I'm just afraid of that I possibly not going to explain well in English to you because you don't really want to ask me to explain to you in Bahasa. Okay, but now I think I'm probably going to miss out something. In Bahasa, it's just the same thing that I was trying to explain to you in English before. Yang penting, bila awak tengok dalam satu-satu persamaan ni, awak kena tahu macam mana dia diletakkan dalam persamaan tu. Sebagai contoh, bila awak dapat dalam equation ni, sebagai contoh, dia letak kat sini 180 darjah. Dan saya pun bagi tahu, saya akan tengok dekat, saya tak pernah cakap kata saya akan ambil dia satu-satu dan saya akan cakap kata saya akan ambil hanya dekat 180 darjah. So, mestilah dalam satu keadaan yang mana yang ada yang ini akan reflect dengan 180 darjah. Sama juga bila awak tengok dekat jawapan yang ada dekat sini. Bila awak tengok jawapan yang dekat sini, kan saya kenapa bila saya buat untuk dapatkan sum of angle yang sama dengan 180 degree tu, so saya boleh, lepas tu saya boleh tentukan sama ada point tu berada pada atas root locus atau tak. Sebab dengan adanya 180 degree ni, dia akan reflect kepada definition of root locus. Faham? Faham? Nak tanya? Guys? I take it as you can understand well on that. Okay, let's continue with our example here. So the sigma A that is equal to summations of finite poles minus summation of finite zero over number of pole minus number of zero. So the pole value will be 0 and as well as minus 57.47, and we are going to have the summation of these two poles in this parenthesis, minus 80 for the finite zero that we have over number of poles 1, 2, 2 minus 1, and we are going to have it to be at 22.53. Got it, guys? Anything that, any questions that probably you are having anything that you would like to ask, guys? How do I get 2? How do I get 1? No? No question?
So I want to ask,
Mhm.
how do you get the number of poles?
Number of poles. How
Two.
many poles that I have here? In my consideration here, how many poles? 1, 2. That is number of poles. How many?
Okay.
0? 1. So that's why it become 1. Any other question? Guys? Okay.
No, sir.
All right. So just please, by all means, try to substitute k equal to 0, and so up to k equal to 2. Oh, no, it's just going to be up to k equal to 1. And try to get the same answer of this. Can you get that? Can you get those that we have here? 180 degree and 180 degree. You can use radian if you like to use the consideration in radian. But if I were you, I'm just going to have it to be in degree. Up to you guys. Okay. No question. Once when k equals 0, so I'm going to have it to be 1 time pi, or 1 time 180 degree over 2 minus 1 over 1, so it will be 180 degree. And then when k equal 1, I'm going to have it to be 3 pi or 540 degree. And definitely this 540 degree is equal to 180 degree. Do I need to consider the next k, which means k equal to 2? No. I do not need to do that. Okay? Because we already have the value when we increase the k value, and at that the current k value that we consider, it's already repeating what that we have had in the earlier value of k. So at that point, at that k value, we are going to stop. What that does, what will be in use for our plot, it will be the one that will not repeated another. So we are just going to have it to be as the k equal 0 to be in our plot. Got it? Would you like me to explain in Bahasa on that? No?
Yeah, yes, sir.
Ah,
Sir,
yeah.
value of K tu kita just substitute je ke nanti?
Yep. Because k is always going to be in this formula that we have here. That's why I get back to the general rules that we have, which rule number 5 will be the implementations of this formula. And what that will be in the formula, you're going to have k, with the consideration of k, 0, plus or minus 1, up to plus or minus 2, plus or minus 3, and so on. Got it? And the point in between that, I did explain to you whether or not you need to consider plus 1 and minus 1. And we can have the conclusion that even if it's going to be either plus or minus, you're going to end up at the same point of the angles. Got it? Got it? Okay, I'm going to get back to the request of that come from your friends. Your friend want me to a bit on the explanation of this in bahasa. Kita buat ni, kita ada k dengan nilai kosong, plus, minus 1, plus, minus 2, plus, minus 3, sampai berapa banyak yang kita boleh buat. Cuma kita akan berhenti di satu tempat yang mana bila apa yang kita dapat dengan kita tambahkan nilai k tu, dia jadi nilai tu yang kita dapat mengulang nilai yang kita dah dapat sebelum ni. Macam contoh yang masa kita guna k sama juga kosong, kita dapat 180 degree. Lepas tu kita buat pula k sama juga 1, kita dapat 180 degree juga. Sebenarnya kita dapat 540 degree. Tapi 540 degree ni samalah tempat dia dekat 180 degree. So kita tak buatlah benda tu berulang-ulang. Sebab dia akan tunjuk tempat yang sama. Point ataupun garis yang kita nak tunjukkan 180 degree tu adalah pada tempat yang sama. Jadi kita berhenti. Dan seterusnya saya masukkan, saya kata apa yang kita akan guna dekat dalam kita punya plot. Kita guna yang mana yang tak termasuk dalam yang berulang tu lah. Faham tak? Katakanlah K sama juga 0, lepas tu K sama juga 1 dah berulang. So kita guna lagi tak K sama juga 1 ni atas kita punya plot tu? Tak dah. Kita guna takat K sama juga 0 lah. Faham?
Faham, sir?
Okay. You okay kan? Bahasa Melayu, you tak perlukan saya pakai bahasa Melayu baku atau bahasa Melayu KL kan? Saya cakap cara yang saya cakap ni pun awak boleh faham. Kalau awak tak boleh faham, awak tanya lagi.
Okey, sir.
Saya ubah lagi.
Sir,
Ya.
satu lagi masalah. Macam mana saya nak tengok kalkulator pi dengan radian tu?
Ini soalan yang paling susah saya pernah dapat ni.
Saya pun confuse kalkulator baru.
Awak cuba tanya ni tengok. Awak cuba tanya. Kan awak ada dekat dalam awak punya mod tu kan. Kalau tak salah saya, that is going to be where that you can actually find. Mod ataupun option. Kalau yang baru mungkin option. Okay?
Oh, okey. Ada sir, ada.
Okay. Kalau tak ada juga tu awak tanya balik manufacturer tu lah. Okay? Right guys. Saya sambung. Ada soalan lagi? Do you have any further question guys? Do you want to have some time to digest on this? I think we're just going to go for another rule or another step. Then I'm going to allow you to have some time for you to digest what that we have learned. Can we do so? Guys, can we do so? Can we?
Kan, sir?
Okay. Okay, we are going to have the other step that will be known as the step that we are going to determine the breakaway and break-in point. But before that, let's get back to what that we have in the actual rules that we're supposed to have in general for us to come out with the plot. So the rule number 1, 2, number of branches, symmetry, that will be symmetry about the real axis segment, starting and ending point, behavior at infinity. They are all basic rules that we need to have, which means that it will be most likely you need to consider these 5 rules at least before you can actually come out with the plot of the root locus. Or these 5 rules are actually compulsory for you to have in your consideration. Okay, then we are going to move to the refinement of the plot. So on this refinement of the plot, or the one that we are going to have it to be for refining the sketch, one of the rule will be real axis breakaway points and real axis break-in points. There will be 2 difference that either the points on the real axis will be known as breakaway or break-in. How do we have this to be in the exact term that we need to refer to? The breakaway means that whatever that we have in the consideration on real axis, it will be whenever that we want to have the continuations of the locus to go to k equal to infinity. That will be breakaway. break in whenever that we are going to have the point that will be the point that we need here to be the point that will be the point that will come into the real axis segment, and the real axis segment will be at k equal to infinity. Okay. Let's get into what that will be at k equal to infinity, and k that is going to, the one that is going to go to k equal to infinity. We have got these two. If let's say we just refer to the real axis segment, it will be breakaway point if let's say the real axis segment that we are going to have in our consideration will be at k equal 0. Okay, let's look at this. So we have this on our plot, on the actual plot of this MATLAB plot. I want to enlarge this. Right. What that you have here, it will be the point that you have that represent the point of pole at 0. This is going to be pole at 0. And this is going to be where that you are going to have it to be as. Guys, sorry, this is going to, this is something to do with my cursor. The point that will be at pole equals 0. This is the point at where we are going to have our pole is at minus 57 something, and this is going to be the point of which our 0 is at minus 18. Got it? Got it? Guys? Hello? Let me just write down the exact point, the exact value of the point. This is at 0. This is at minus 57.47. This is at minus 80. Okay? Anything that you would like to ask? Anything that you want me to clarify? Anything else? Got it? Things should be fine. Hello? Okay. So as we do have this point that refers to what that we have for the pole and 0, we also know at this point k equal 0. At this point k equal 0. At this point k equal infinity. How do we know this? Because we already have the considerations of start points and end point before this. Got it, guys? Do you have a question on that? Hello, guys.
No, sir.
Okay. Then we know that in the definitions of locus, there will be the plot that reflect to the variation of k from 0 to infinity. What that we do have was just a straight line to represent real axis segment when we consider up to rule number 4 or step number 4. That is the actual thing that we have had in our solution. At step number 4, we're just going to have up to real axis segment. We have yet to have this semicircle, like the blue semicircle here, and like this green semicircle here, or like the oval that we have in the in the entire plot. We don't have that yet. But by having this real axis segment, so definitely we need to know what that's supposed to be, at least the idea that would be the point that we are going to find out for the point of the real axis that we need to know in the next part or next step of our plot. As this is k equals 0, so we need to know the point that will be named after breakaway point. Why? Because it will be traversing from this k equals 0 up to infinity. Got it? You got the idea? Do you want me to explain in Bahasa on that? Guys, your
Boleh,
call.
Yes, sir.
Okay. Awak, setakat ni awak tahu ada real axis segment sahaja. Kan? Jadi, awak ada dua garis je lah. Yang ini, garis ni dengan garis ni. Dan awak tak tahu, setakat step number 4, awak tak tahu pun awak nak cari breakaway point ke break in point. Macam mana awak tahu? Sebab akan awak ada ni K sama juga kosong, K sama juga kosong. Jadi mesti ada satu point yang mana akan keluar daripada garis ni. Sebab tu kita panggil dia breakaway point. Faham? Faham? Sebab point yang kita akan sebut tu dia berada pada real axis. Dan apa yang kita buat? Kita buat berkenaan dengan kita punya root locus plot. Right, guys? Okay. Okay. Let's continue with the explanation of break-in and breakaway. The next point that we have on the real axis segment, as we have it here, we're going to have this, and as well as this, and the next one. What that's going to be the next one? The next one will be at k equal to infinity as well. Why? Because what that we are going to have in the definition, the real axis segment will be just the existence of a straight line on real axis whenever that we are going to have the total of finite poles or finite zeros or combination of these finite poles and finite zero equal odd number. So this is odd because we are going to have them to be as the total of 1, 2, 3, and it is odd. With the 3 that we have had, it is odd. So what will happen to the real axis segment? There will be an existence of real axis segment from this point towards. Do we have other finite poles, finite zeros? Do we have that? No. So it will be towards infinity. You got the idea now? Guys? No. So what else that we can do here? If let's say we want to look into this further detail, we can actually have this to be as we know the directions of our locus. I mean, the plot that we are going to have for the root locus. We're also going to call it in the layman term as a locus. Do you have anything that you would like to ask further? Guys, anything? Definitely it's going to be this direction because it is at k equals 0. It is at k equals 0. It will traverse from 0 to infinity. So we are going to have one point that will be known as breakaway for this real axis starting from 0 to minus 57.47. And we are going to have one point that will be known as break-in point. Why? Because they must be a locus that we are going to have from the other point that will be coming to this real axis segment that we have on our plot. Okay. Is that clear, guys? But this is just applicable to this case. Okay. Anything? No. Okay, that's good. And this will be one of the way how that we can actually find the break-in and breakaway point. We are going to use this differentiation method. What that we are going to have in this differentiation method, let's get back to the common or general explanation here. And your question, do we have other method? Yes, we have transition method that we can actually come out with the point of this breakaway or break-in point, or both breakaway and break-in point. And there will be the case in which that you are going to just have breakaway point. There will be a case that you are going to have just break-in point. So that's why I clearly highlighted to you that whatever that reflect to the break-in and breakaway as what that we can see here in this example will be just dedicatedly for this example, right? Yes. Anything else? Anything that you would like to ask? No. In terms of understanding, you are all so good, guys. I'm going to consider you all as a fast learner. Right. Anyhow, this is what that we are going to have in the differentiation method. We can have the differentiation that will reflect to the k value will be dk over d sigma with the conditions of the sigma, if let's say that will be the domain that we are going to look into, equals 0. Okay, let's look at what that we have here. So normally we just going to actually substitute the domain of S that we need to have it to be in the consideration to avoid confusion. But we can just make use or have it to be in the S term if you want it to be that way. So it will be d over ds for the equation that we have as ns over ds, that will be equal 0. We can do it to be as this way instead of we have the first the earlier definition of changing the s to be equal to sigma, then we are going to have it to be considered as d sigma. We can directly use d over ds. So what are going to be the value that we are going to have it to be here? It will be ns over ds. So which means that what that we actually want to look for, we actually want to look for the value that we are going to have it to be as this differentiation of the equation. And we equate the differentiation of the equation equals 0. Right, guys? Try to look into this. And once we come back, I'm going to further explain to you on this, on how that you can actually have this to be the one that you can realize it on this calculation. Okay. Okay, guys, how long that you need to digest this step number 4 and to just look into or have an overview for this step number 5? How long you want? 5 minutes? Is it enough? Guys, your call.
5 minutes, sir.
Okay, that's good to know. I'm going to give to you 8 minutes. So you can actually look into what that you are going to have in this consideration. Let's get back at 6. Okay, guys. Anything before I start trying to explain this to you? Anything that you would like to ask, guys? If let's say you already can somehow understand this and you would like to ask something before I'm going to continue with my explanation, do you have anything? Anything, guys?
No, sir.
Okay. Let's get what that we supposed to have for this breakaway and break-in point. In actual, this break-in and breakaway point is just the equation that we actually have it to be in the consideration for which that there will be the point that the k itself will be changed in terms of the straight line shape to the other. I would say so because what that we are going to have on this point for the k, it will be the point for which the shape that we have for the locus, which is straight horizontal line, to be changed to like the curve that we are going to have for the root locus. Okay, that will be the way that I'm going to put it in my understanding. And in exact, when you refer to the plot that you are going to have it to be as the actual plot later, you possibly going to have the same conclusion as mine. But anyhow, in the actual considerations of what that we have here, we are actually having this to be on the consideration as 1 plus kgs hs is equal 0. This is going to be the characteristic equation that we have had for the consideration of the closed loop transfer function. And we are going to have kgs hs is actually equal to -1. The same thing as what that we have had as we try to find out whether or not the point that we are going to have to be on the locus, things that we have had earlier when we consider the plot that we have had by the plot that we have had by using the vectors method. We are using the same equation 1 plus kgsHS, and definitely in the definition it also being stated that this 1 plus kgsHS equals 0 is the fundamental of the root locus. So having this to be this way, we are going to have our equation. If let's say we are going to put the equations that kgs hs equal to -1. So what that we do have here in our example will be this, because we have this to be the equation for the 1 plus k. This is going to be the gs. What is our gs? S plus 80 times this 16 over s 0.0174 s plus 1. Can you agree with that? Yes? Can you? So, this is our actual equation, and we put it equal 0. Then as we have this to be in further consideration, we will have it to be as ks plus 80 times 16 over S 0.0174S plus 1 equal minus 1. The same thing. Okay. So we can have it to be as this one. Got it, guys? Got it? But we do not want it to be as it will be with this condition of 0.0174S. And definitely we do not want it to be in that way. That's why we have it to be changed to be as S plus 80 over S plus 57.47. Got it, guys? Do you have a question on that? Hello? Guys, any
No,
question?
sir.
Okay. Then when you have this d over ds, it is actually you differentiate k. And if you consider this, you are going to have it to be as k is actually the equation that you are going to have with this. So you differentiate the k. That's why we are going to put it as d over d sigma k. So d over the sigma here, as in the general rule that we have had, the sigma here, we remain as S. So that's why we are just going to have d over ds. And k, as what that we have defined, we are going to have it to be as S plus 80 over S plus 57.47. You got the idea now, guys? Hello? Any question?
No, sir.
Okay. Then we can continue with the consideration of this. So how are you going to do this, guys? If let's say you consider your maths in your secondary school, dfx over d over dx of fx gx. How you consider this? It's just going to be the same thing. D over dx of fx over gx. How are you going to get the answer, guys? It's going to be, hello? How are you going to do this, guys? It will be equal to g prime x. Am I right? Am I right?
Yes, sir.
No? Guys, please focus. How I'm going to consider this. This is not right. If let's say I'm going to have d over dx of fx over gx, how I'm going to consider this? This is your differentiation, guys. I'm going to have it as, hello, gx times f prime x minus, guys, fx times g prime x over g squared x. All right. So I need to have it to be in my consideration, and it will be look like this. And once I put everything in as they are going to be the equation that will be equal 0, I'm going to have this, and I'm going to have this two value of S1 and S2. Anything that you would like to ask, guys? No? Guys, do you have any question?
No, sir.
Okay. Try to come out with this S1 and S2. Try to do it on your own. I'm going to allow you for about 5 minutes and ask me if you do have a question. Right? Hello, guys. Can you reach up to the answer, guys? Did you get this S1 one value of one of the S value will be minus 37.5 and the other will be minus 122.5. Did you get these two value?
Yes, sir.
Okay, I hope so. And if let's say you do not have a problems, I'm just going to conclude this part. If you do have a problem, by all means, guys, ask me. Hello? Okay, you can see that. In the actual equation, if let's say you are going to have the K value that's supposed to be when we have this K GS HS is equal to -1, and we have this K is actually having this numerator and denominator. I'm just have to have this to be as capital D. How do I get this numerator over denominator from the equation that possibly be when I consider GS times HS? That's why I put it as this K times NS over DS is equal to -1. So what that I'm going to, sorry, it's equal to -1. So if let's say I'm going to have, I want to have the K value in actual K is equal to minus DS over NS. Got it? Guys? And I want to equate the equation to be equal 0. Because that is what that will be in my consideration for the breakaway point and break-in point using transition method. So I'm going to have this ds over minus ds over ns equal 0. For the ds over ns equal minus ds over ns equals 0. So if you look at it in the considerations of actual consideration, it's just going to be the value that you don't really have anything that you actually going to bother about the arrangement of ds and ns. That's why you can have it to be as d over ds ns over ds or d over ds of ds over ns. It will come up with, or it will somehow turn up to be as the same answer. Okay, hopefully you can get this S1 and S2. And anything else? Again, do you have any question that you would like to ask before I move to the next rule?
No, sir.
Okay, good to know that. That was your response, guys. Okay, the next one. Calculations of J omega axis crossing. Okay. Once it's come to this, I mean, this two that is going to be the calculations of this J omega axis crossing, as well as real axis breakaway and break-in points, angle of departure and arrival, plotting, and this plotting and calibrating the root locus is just the one that you are supposed to have once you want to refine the plot. Definitely you are going to have this. But as for the rule number 6, 7, and 8, one of the other way to have it to be as how are you going to consider about the existence of these rules number 6, 7, and 8, or is it anything that related to your problems that you need to do with rule number 6, number 7, and number 8, because they are actually optional. Maybe there will be the case that you are going to consider that you do not need to have rule number 6 in your consideration. Maybe you do not need to have the rule number 7. Maybe you do not need to have a rule number 8. There will be such possibility that you are going to have whenever that you want to come out with the actual plot. So it is optional, but the optional will be depending on what that we are going to have for the system. And this is not as the optional either. It is going to be without the consideration you are going to get the right answer, but it is compulsory optional depending on the condition. You got the idea now? Yes? Some of the plot will not be within the consideration of this rule 6, 7, and 8. Okay. One of the way of how that you can know about the existence of real axis, breakaway, and break-in point to be in your consideration is by looking at your behavior at infinity. But for this case, you won't be able to have I'm going to say that the direct imagination, if let's say a kind of that, a kind of something that you can directly imagine, if let's say you refer to the behavior at infinity. And one of the other way is going to be by looking at the real axis segment that you have. So you know from this real axis segment, it must be the breakaway point and as well as break-in point. If not, how can you get the plot that will be in the variation of k beginning at 0 and ending at infinity? All right, guys. Till that point, anything that you want me to explain in Bahasa, anything, or anything that you would like to ask as your further question, anything else?
No, sir.
If let's say we are going to have this behavior at infinity consideration in our plot, which means that we are going to put this sigma A to be in our consideration and as well as theta A, how are we going to have it to be on the plot? So what that we have for the sigma A, it will be plus 22.53. 22.53, so it's going to be about half or less than half of this. So I can just take it to be here. This is going to be the point. So I'm going to have this to be known as I don't want to use this card. What is the okay? This I'm going to have this to be known as sigma D. Okay, sigma A. Sorry. Because there will be another sigma D that is important when we are going to have our design later. That will be the dominant poles. Yes, just one. To use this that color, the sigma A. So the sigma A equal to 22.53. And then the theta A, it will be 180 degrees. So I'm going to have the plot to show my behavior at infinity to be look like this. So it is actually, this is how the overall of your plot will be look like. If let's say you are going to have the plot up to infinity, it will be just like a straight line. And your question, why, when you have it to be plotted by using this MATLAB, it is not going to be as what that can be described as the overall plot for the at the condition of k equal infinity, as we have it to be as the behavior at infinity. We actually trying to have the consideration of how the plot will be look alike when we have the plot up to k equal infinity. You got the idea? Nice. Anything that you would like to ask on the behavior at infinity and how that it will be related to k equal to infinity?
No, sir.
Okay. So if let's say we are going to have the plot up to k equal to infinity, we will have it to be look like just a straight horizontal line. And I have raised the condition that you may have the question, how can the MATLAB come out with the plot that I'm just going to have bit of 2 bits or 2 line of the horizontal line, but in between that 2 line or somewhere within the 2 line, I'm going to have this oval curve or oval shape of the part for the root locus. How can I actually have the plot that is not similar to what that I have considered as k behavior at infinity? Guys, anything other than that, that probably going to be your question? In order to explain this, it's going to be just as simple as whenever that you look at the something that is just having a small difference on a straight line will be look like just a straight line. Imagine that you are going to have this to be as the straight line that's starting from 0 up to infinity. So infinity will be ended at this point. So this is going to be 0. This is going to be things that you need to imagine. Why you are going to have just a straight line to show the behavior at infinity. How about this oval shape? When you look at it to be so big, within this 0 to infinity, this oval with the height of, I'm going to say it is something like, you know, like the one that you are going to have for the height of this, it will be just up to 40 something. To compare this 40 something, and this is going to be 40 something as well, to compare with the oval part of this, whenever that you look at it, it is just going to be like a single point that we have here. So imagine if, let's say, you compare this to infinity, 0 to infinity, means that the infinity will be up to the length that you can't even imagine. So this oval will be just like a straight line. You got the idea? You got the idea? Okay. Okay, I'm going to explain to you in bahasa. Katakanlah awak dah ada nilai yang sangat kecil ni di atas satu line yang sangat panjang, awak akan nampak ada seolah-olah dia straight line dekat sini. But one thing, instead of it will be at 0, it will be a bit longer than that. Why? Because of this oval shape. It seems to be as what that you can imagine by looking at the the tails of the or something that the tail of something that is going to be in the comparison of small thing to the things that bigger than it. So it will be telling with something that more than the straight line that you possibly have due to this bit of oval shape that you have on for your root locus. Right? Anything, guys? Not so sure whether you are still following me or you are already somewhere else. But anyhow, all right, guys. Hello, guys.
Yes, sir.
Okay, let's turn on your camera, guys. So I'm going to allow you to have these 5 minutes. So at 6:38, I'm going to ask you to turn on your camera. So I'm going to screenshot whoever that are actually in the session. So I'm just going to consider those who are in the snapshot will be as attending the session. Can we do so? Nice. 5 minutes. And
Okay,
please
sir.
prepare to turn on your
Yes,
camera.
sir.
Okay.
Kena semua orang kena buka kamera guys.
Danish Hakim.
Hello. Do we have Muhammad Adam Who is this? Muhammad Adam Hakimi. Do we have Adam Hakimi in our session? Okay.
Ada dia.
Okay. This is going to be the first group out of 4 group that I'm supposed to have in this session. Okay. Let's move to the next one. Just please wait and keep turning on your camera for the meanwhile. Just one moment, please, guys. Hajar Nur Suhaila, are you actually in the session? Nazmi bin Salman, Devon, are you in the session? Muhammad Wafiuddin, hello.
Saya dah buka dah kamera saya.
Okay, just turn it on. Okay, I can see you now, Wafiuddin. How about this, Devon? Are you in the session? Are you actually in the session, Devon? No, I don't think so. So I'm going to remove you from the session. Do we have Nick Muhammad Daniel in the session? Nick Muhammad Daniel. Okay, that's good.
Yes, sir.
Okay, it's okay. I can see you. This will be the next group. Please wait, guys. Let's go for the next. For the group, I'm going to go for this group number 3. Okay. Okay, do we have, okay. All of you are in the session. Let's go. Let's move to the next one. The last one. This Dini Muhammad Ikhwan. Do we have Dini Muhammad Ikhwan in the session? Okay, that's good. Just one moment. Right, guys, let's get back to our lecture. Just one moment, please, guys. Do we have Osman in our session? Okay. Yeah, you are actually in group 2. That is fine, Osman. Do we have Nurul Darwisha?
Ya, saya, sir.
Okay.
Saya.
Okay, I have already received your request for the MC.
Okay.
Okay. Have you attached the MC as well? Did you attach the MC as well?
Already attached the MC in Unicode
Okay.
link.
Okay. Good to know that. Right. Okay. Right, guys. Let's get back to our discussion here. So the next rule or the next step that we possibly going to take after we have this real axis breakaway and break-in point, possibly it's going to be on the determination of departure angles and or arrival angles. We possibly going to have both departure and arrival angles for our plot. We probably going to have just either one, and we probably don't even have any of these departure and arrival angles. That will be the next step. And as for the case that we have here in the example one, we do not have this to be in the consideration for the actual plot or for the completions of our plot. We don't need to have this to be in the consideration. And the next one will be in the step number 7, and possibly it's going to be the rule number 8. The next rule after what that we are going to have on the determining of this departure and arrival angle. It will be on the determinations of the imaginary axis crossing. So this imaginary axis crossing is definitely the considerations that we can know about whether or not it must be in the in our consideration for the complete plot or one of the steps for our solution or not. We can know about its existence by referring to the behavior at infinity. So from the behavior at infinity that we are going to have for such system that we are considering at, we will know whether there will be imaginary axis crossing for the plot that we are going to have or not. But as for the break-in and breakaway point, we can have it to be considered, but it is still something that will not be clear if, let's say, we are just referring to the behavior at infinity. The next one, it will be on the departure and arrival angle. We can also refer to the behavior at infinity as one of the reference that will help us to know about whether or not we are going to have this departure and arrival angle. But other than that, we can actually know about this existence of step number 6 as we look at the locations of our poles and zero. Okay, I'm going to have the explanation of this step number 6 and 7 once we have the problems that consisting or must have the consideration of this step number 6 and 7 in that particular problems. Then I'm going to discuss further on that. But right before that, let's look at what that we supposed to have as the general definition of rule number 7 and 8. So calculation of J omega axis crossing is the consideration of which the root locus crosses the J omega axis. That will be the necessity when we have the plot that we are going to have. We know it will be crossing the J omega axis crossing, then we need to have this calculation of J omega axis crossing. And as for angle of departure and arrival, it will be the one that we are going to have them for the complex poles and zero. I'll explain further on this existence of departure and arrival angle since we already exceeded the times that we're supposed to have for today's session. So I'm just going to stop here. But before that, please wait. I'm going to share with you all your QR attendance. Just one moment, please, guys. So, guys, please do not ask me again and again whether that you are going to have your session on. Are you going to have tomorrow session or not? Please do not ask me that because the tomorrow session is the session that you are actually having it now. Okay, all right, guys. We have it to be earlier. Just one moment, please, guys. And another thing, guys, I don't think that you can actually change group since all of the group is already full with the allowable capacity of the group that is 20 students per group. Just one moment, please, guys. Here you go, your QR attendance, guys. Thanks, guys. Thanks for your time. Assalamualaikum.
Sir, saya scan tiga-tiga tak boleh sir.
Oh,
Sir,
Expired, sir.
You
You are
expired, sir.
expired, sir.
just one moment, please. Can you?
Expired sebab dia sampai 6.40 je tu, sir.
Oh, okay. So I'm going to extend that. No worries. Oh, anyhow, you can just dismiss because I do have your logging records. No problem. Thank you. I'm
Thank
going
you,
to
sir.
just mark
Thank
for
you, sir.
your
Thank you, sir.
attendance. Thank
Thank
you.
you, sir.
Thank you, sir.
Thank you sir.
Thank you, sir.
Thank you, sir. Happy iftar.
Selamat
Thank
buka,
you,
guys.
sir. Happy iftar, sir.
You all too. Happy iftar. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Hello, sir. Sir. Scan lah. Dia kata,
Ha?
dia kata QR expired.
Tak apa, tak apa. Okey. Sebab saya ada pun awak punya attendance. So awak boleh leave the session.
Okay, sir. Thank you, sir.
Ha. Saya dah ambil gambar pun tadi. Saya boleh tengok juga.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.